Variables. Everything changes. We know that everything will change, but you need to change the right thing, at least in your experiment. So what are variables and how do we use them? So let's answer the first question. The verb to vary means to change, usually in a continuous way, something that changes slowly over time, or quickly over time, but over time at least. Variables are things that change in a science experiment, and there are different things that can change, and they can change in different ways. Choosing what to vary will be one of the most important parts of your experimental design. So the three main types of variable are independent variables, which are the things that you change deliberately. And then there are the dependent variables, the thing that you see change in your results. So the dependent variable depends on the independent variable. That is how you make your conclusions, by changing an independent variable and then seeing what happens to a dependent variable. But to do this, you need to make sure that everything else is the same, and these are our control variables. Everything that might change in an experiment, you need to keep the same. So how are they important? Hopefully you're already seeing how they're important, but every experiment uses this process. You set the independent variable, you measure the dependent variable, and you analyze the difference in many tests. So let's look at this machine here that we've made. It's just a white box with a red button on the top, and we have a slider on the left. And if we press the red button, we get a little dot on our piece of paper. Let's move the slider and then press the button again. The dot has moved. Let's try that again. The dot has moved again. And every time we move and press the button, the dot moves to a different place on our piece of paper. And afterwards we can look and see if there are any important things that we can learn. So, repeating yourself. Quite often, repeating yourself is a bad thing, but in science, you need to be able to repeat yourself. It is vitally important. So you need to think about this when designing your experiment. Why is it important to repeat yourself? If you set variables and do the tests, analyze the work, and your results support your hypothesis, that means you are right, and you are done, and you win a Nobel Prize, right? Wrong. If you want to prove that you have a new discovery, you must be able to show that you can do it every time. If you do something once by accident, then you are lucky. But maybe there's a control variable that you missed. Maybe there is something else going on that you're not sure about. Maybe if you do the experiment many times, it will not go the same way. So you need to make sure you do your experiment enough times that you are happy that every time you do it, you will see the same results. So let's just have a quick look at our box again. What is the independent variable here? And what is the dependent variable? And what is the control variable? So just answer that to yourself. So what you should have come up with is the independent variable is what we change at the start, so this is the slider mechanism. There should only be one independent variable in each experiment. If you are changing more than one thing, then really you are doing two experiments at the same time, which is often a good idea, but you need to make sure you do each one properly. The dependent variable is the thing we measure, so it's our data, and that means it's the green dots on our piece of paper. That is our dependent variable because every time we change the slider, we get a different green dot. And then finally, control variable is everything else that might change but doesn't change. There will be many control variables in every experiment, and those are everything that we find in our box. So all of our control variables are found inside this magic box, but we assume that the magic box is a machine and it does the same thing every time. Maybe we are wrong, who knows, but this is how we try to think about our control variables. We make our control variables into a machine that will do the same thing every time to the independent variable. So a different experiment might use different control variables. So let's say we change our experiment and now we have this set of control variables. This different box represents a different set of control variables. And we can do a different set of experiments, and looks like we're going to get a different set of results. That's interesting. So I know what you're thinking here, right? That is just another independent variable. By changing the control variables, you've just made another independent variable in your experiment. So well done. If that's what you were thinking, good job. Every time you change anything in your experiment, you make it an independent variable. So some changes are very small and will not affect the experiment. You can sometimes say that effects are negligible, which means you can ignore them, but you need to be sure and you need to find all the changes that will affect the experiment that are not negligible. So everything that's not negligible should be either measured as a dependent variable or as an independent variable, or isolated, kept the same or kept away from the experiment. Every independent variable that you use will multiply the work that you need to do, and this is where it gets a little bit complicated. Here's our first set of control variables, our white magic box, and this is the data that we got, the set of green dots. This was 6 different tests. We changed our slider to 6 different places, and that's the data we got. And then we have a different set of variables, and they provide a different set of data. That is 6 more tests. So now we have 12 tests we need to do. Let's have another set of data, another set of control variables. They give us another 6 values, and another 6, and another 6, and another 6. What we can do is change our slider to 6 different places. And then we've taken another control variable and changed it 6 different times. And now, how many data points do we have? We have 6 on every sheet. We have 6 sheets. So now we have 36 pieces of information when we have 2 independent variables instead of 1. Change your second variable 6 times and you have 36 different measurements to take, but you can take this even further. Let's say we change a third variable, so our button is now a different color, and we get 6 more different sets, another 36 data points. But look, we've only changed that third variable once. Really, we might want to change it more than once. If we change it 6 times, the same as the other 2 variables, then we will end up with 36 times 6 different data points. So that would be 216 different data points we must collect to do all of our independent variables. So when you design your project, you should now see why it's important to keep things simple. Try to make sure that you can keep everything the same except just one or maybe two variables, and this will make collecting data much easier for you. The same as everything in your project, if you put a little bit of thought into it at the start, it will save you a lot of time at the end. There is an old saying, proper preparation prevents poor performance. And there's a slightly longer version of that saying which you can find for yourself on the internet. It includes a bit of extra P. So remember, in review, the simplest way I can say this, the independent variable is what you change. The dependent variable is what you measure. And the control variable is what stays the same. That is how you use the three main types of variables.